Good morning. Today we will discuss the vector autoregressive model. We will discuss what do you actually mean by vector autoregressive process and what do you mean by vector autoregressive model, what are the possible model that we have under this head, how do you estimate the parameter of such model, and how we go for hypothesis testing. So, let me start what do you mean by vector autoregressive model. Now, when we are not confident that a variable is actually exogenous, it is natural consequences will be to treat each variable symmetrically. In the two variable case, time path of yt sequence will be affected by current and past value of the xt sequences. And at the same time we can assume that both also xt sequence is in turn affected by current and past values of yt sequence. So, we treat both the variable yt and xt symmetrically. Now, to start with, assume both yt and xt are stationary. Now, consider a bivariate yt xt of the first order VAR model. Yt is expressed as a function of xt and also the past values of xt at lag 1. Similarly, yt is also expressed as the past value of yt at lag 1. Similarly, xt is expressed as a current value of yt as well as past value of yt at 1 year lag and past values of xt at 1 year lag. Now, the error terms of the structural shocks epsilon yt and epsilon xt are white noise innovation with standard deviation sigma y and sigma x and a non-zero covariances. Now, both the variable yt and xt are endogenous. Why? You can see that yt is dependent on the current values of xt as well as the past values of xt, and if there exists a innovation in epsilon yt, that is error term of the yt variable, then it will directly affect the current values of yt. And in the next round, since current value of xt is dependent on the current value of yt, it will also have an indirect effect on xt. So, any changes in innovation epsilon t will have both direct as well as indirect effect. Similarly, changes in epsilon xt in the first instance will affect the current values of xt. And since the current value of yt is in turn dependent on the current value of xt, it will in turn affect the current value of yt. Hence, the error term epsilon xt will have both direct effect as well as indirect effect. Now, shocks epsilon yt affects, as you see that epsilon t affects yt directly and xt indirectly. Now, there are 10 number of parameters to estimate. Now, the above two equations constitute first order VAR because longest lag length is unity. The structure of the system incorporates feedback because yt and xt are allowed to affect each other. For example, b minus b12 is the contemporaneous effect of a change in xt on yt. Similarly, yt is also influenced by past values of xt, and error term of both equations are white noise. So, as I have already discussed, if there occurs a change in the error term of yt equation to start with, it will affect yt and this in turn will affect xt, as xt is in fact explained by yt, that is the coefficient of xt in yt equation is different from 0. Thus, there is both direct as well as indirect effect of the change in the error term of any equation. Now, in this context, so in the VAR model, what we do? What we basically consider the integrated system. There is two-way interaction between the variable yt and xt. We did not treat either xt as exogenous or either yt as exogenous. We treat both yt and xt are dependent variable, they are endogenous, and both yt and xt are endogenously determined by the current as well as past values of the variable. At the same time, the changes in the distribution epsilon yt and changes in the error term epsilon xt will have an direct as well as indirect effect on the dependent variable of the model, that is the two endogenous variable yt and xt. Now, in this context, we can distinguish between two types of VAR model, the structural VAR or primitive VAR. It is called structural VAR because it describes the basic structure of the model, and VAR in standard form. This is basically the reduced form of the structural model, and this is derived from the structural VAR model. So, in a two variable case, the matrix representation of the system takes the form like that. That is, here you have two-way dependence between the yt and xt, and matrix notation you can have vyt equal to gamma naught plus gamma 1 yt minus 1 plus epsilon t, and this is basically the reduced form of the model and VAR in standard form. So, this kind of model is derived from the structural form of the model by this transformation. So, structural VAR is not a reduced form. In a reduced form, representation of y and x are just a function of lag value of y and x. To solve the reduced form model, write the structural VAR in matrix notation, and from that you have yt as a function of yt minus 1. So, this is the VAR in standard form. So, byt equal to gamma 1 naught plus gamma 1 yt minus 1 plus epsilon t. From that you derive yt as a function of yt minus 1. So, in this case you can see that yt is explained only as a function of endogenous variable, lag value of the endogenous variable, and hence it is known as VAR in standard form. Now, before estimating the model, we will present the stability condition for the model. Now, stability condition requires that all roots of the characteristics roots of the polynomial must lie outside the unit circle for VAR P. Now, after estimating the reduced form, we will discuss the information to get from the obtained estimate, that is grandeur, causality, impulse response function, etc., and that will be discussed in the next class. Now, the most common example of the structural VAR model is developed by SIM, and SIM consider money supply, interest rate, income, and from that he considered a VAR model where there are interaction between the money supply, interest rate and income, and from that he has derived the structural VAR model. Now, stability, as I have discussed, that in order to estimate a suitable model, the stability of the model has to be guaranteed, and stability of the model requires that all roots of the polynomial will lie outside the unit circle. That is, all roots of this polynomial of order p, because since you have a lag length of order p, that basically implies you are getting a polynomial of degree p in L, and as a result it will contain p number of roots, and all the roots of the polynomial mod value of all roots of the polynomial should exceed unity, that is the all the roots will lie outside the unit circle. Now, if VAR is stable, then it can be shown that autoregressive model has an equivalent MA representation, that is YT can in vector autoregressive model YT is expressed as a function of past values of YT, but in MA representation current value of YT is expressed in terms of past error. Now, if the model is stable, then it is possible to show that the vector autoregressive model autoregressive structure has an equivalent MA representation, and we need this representation because it is very essential to study the impact of impulse response function and also consider variance decomposition, that will be discussed in the next classes. Now, come to the estimation of the model. Now, for estimation of the model, we basically apply maximum likelihood procedure. Now, given the error term, first we assume that the error term are normally distributed. From that, you can generate the joint density function of the endogenous variable given the lag values of YT and the distribution of the joint distribution of the error terms, and from that you can get the log likelihood function and you can perform the maximum likelihood procedure to obtain the estimated value of the parameters. Now, it can be shown that if the model contains the exact number of lags for each of the equation, then OLS estimation are as good as MLE estimation. That is, a consistent estimate of the structural parameter can also be obtained by applying ordinary least square estimate if under the assumption that all the equations have equal number of lags, same number of lag structure. Now, come to the hypothesis testing in a VAR model. Now, here we basically estimate the VAR model by likelihood function and estimate the number of lags. Now, suppose you want to test the hypothesis, the lag length of the VAR is P naught, say P naught, against the alternative hypothesis that the lag length of the VAR is P1. Then what we do, we put restriction of each of these extra parameters and carry out the likelihood ratio test, and likelihood ratio test statistics should follow chi-square m, where m is the number of restrictions into each equation. So, if these likelihood ratio test statistics follow chi-square distribution with m degrees of freedom, then we accept the null hypothesis, that is the lag length r is equal to 0. And accordingly, you can derive the asymptotic distribution of the parameter of the model. Now, in order to determine the lag length of each of the equation, you can use information criteria. Now, most well known accepted information criteria are Akaike information criteria and Schwarz-Bayesian criteria, and we can estimate the Akaike information criteria and Schwarz-Bayesian criteria to test the optimum lag length of each of these equations. So, in order to determine the parameters of the model included in VAR, it is important to determine the appropriate lag length. One procedure is to follow for different lag length for each of the equation. Now, as long as there are identical regression, Each equation of OLS estimate are consistent and asymptotically efficient, but if some of the VAR equations have regressions not included in others, seemingly unrelated regression equation, that is Schur model, provide efficient estimate of VAR coefficient. And in this case, we follow the approach of near VAR, and hence when there is a good reason to get lag length differ across equation, we estimate the so called near VAR model using seemingly unrelated regression technique. That is, if the number of regressors is identical in each of the equation, then OLS estimates are consistent and asymptotically efficient. But if we have some good reason to believe that lag lengths differ, then we have to apply the procedure of estimation of seemingly unrelated regression technique to get the efficient estimate of the VAR coefficient. And in this case, we apply near VAR model using Schur estimation. Now, if at each lag length p, each of the equation contains n p coefficient, and we incorporate intercept term. So, what is needed? Appropriate selection of lag length criteria is very critical, because if p is too small, the model is specified. On the other hand, if p is relatively large, degrees of freedom is wasted. To check the lag length, to begin with, longest possible length given the degrees of freedom under consideration, and estimate the VAR model from and obtain the variance covariance matrix of residual. Take some example. Using quarterly data, you may start with a lag length of 12 quarter based on the a priori information that there 3 years is sufficiently long to capture the dynamics, and estimate the variance covariance matrix of this residual. Now, suppose you want to determine whether 8 lag is appropriate. Now, restricting the model from 12 to 8 lags would reduce the number of estimated parameters by 4 in each of the equation. So, here equation by equation F test on each lag 9 through 12 is not appropriate. Rather, what we do, we put cross section equation restriction in a likelihood ratio test. Note that in a system of n equation, it incorporates 4n restriction to each of the equation, then apply likelihood ratio test, re-estimate the VAR model for the same sample, mind it, for the same sample using 8 lags, and obtain the variance covariance matrix of residual. If the test statistics has an asymptotic distribution, asymptotic chi-square distribution with the degrees of freedom being equal to the number of restriction, and if the restriction of a reduced number of lag is not binding, we would expect that the variance covariance matrix of the residual will be equal to the cases with and without restriction. So, if we find that the variance covariance matrix with and without restriction are more or less same, then we take then we basically conclude that the restrictions are not binding. And if the calculated value of the test statistics is less than the chi-square value at the specified level of significance, we will not be able to reject the null of only 8 lags. At that point, we seek to determine whether 4 lags will be appropriate in a similar fashion. In this class, we have discussed what do mean by vector autoregressive model, what are the types of vector autoregressive model that we have in practical situation, how do you estimate the parameters of the model, and how we go for testing of hypothesis, how do you test of the lag length of the VAR model, and how do you optimally choose the optimal lag length of each of these variable.